It's finally time to talk about logarithms. Logarithms is based on having something in exponential form, and a logarithm is trying to rewrite that, trying to solve for pieces of it. We're going to work on some different properties with logs. Logs are a very, very helpful tool, and I'll come back to this first slide in just a minute, but a logarithm is just an exponent. It's important. A logarithm is just an exponent. So to begin with, what we're going to do is I'm going to give you the following problem. 10 equals 3 to the x. I want you to figure out what x is. What is my exponent? Okay. Do trial and error. Use your calculator. Start plugging in values. You should have an approximate idea of what x should be, but just pause this for a minute. I want you to get my x value to the nearest 3 decimal places, please. So when you started going through doing guess and check, I know 3 to some power has to equal 10. Well, 3 squared is close. 3 squared is 9, and then 3 to the third is 27. So it's definitely closer to a 2. So it's going to be 2 point something, and 3 would go over anyway, so it has to be 2 point something. So then I start looking, okay, well, how close to 2 is it? Is it really close to 2, or is it almost closer to 3? Well, 3 squared is 9. 3 cubed is 27. It's a lot closer to a square, so it's a lot closer to 2. So I might start trying to put in a 1 or a 2, and then I realize those are too big. I have to put in a 0. But then I have to put in a 9, and then rounding the closest, I end up with a 6. Now, there's no other way to figure out what x is up until now. You do not know how to calculate when your exponent is your unknown. That's the biggest thing that we're looking at. Your physical exponent is an unknown. That's your variable. So we're used to having a variable in our base, or having it just as a linear. Now our exponent is actually the unknown part of it. So this is the part where we're going to have to do a little bit more work, and we are going to use logarithms for this. So as I stated, a logarithm is just an exponent. A logarithm is just an exponent. So I'm going to give you an exponential piece, and then I can put this in words. So here's an example. 3 to the 4th equals 81, right? 3 multiplied by itself 4 times gives you 81. How this is written when I speak about logs, 4 is log to base 3, right? 3 is my base, of 81. Okay, that's how we actually rewrite that from exponentially into this log description. A log is just an exponent. So 4 is the log, because it's the exponent, to base 3 of 81. How we write this in log form, this is exponential form, this is log form. 4 is equals log to base 3. That 3 is a subscript down. It's dropped below the log of 81. That's logarithmic form. You will be converting things from log form into exponential form. So from log form into exponential form. And you'll be moving things from exponential form into log form. As I talked about in exponent properties, a lot of times it's hard to go backwards and forwards. This is one case where you have to be very fluid going backwards and forwards between the two properties. So we're going to take a look at base B logarithms. It doesn't matter what the base is. This property will work for all of them. So base B logarithms. Y equals log base B of x. If and only if, IFF, if and only if, b to the y equals x. Now there is a little stipulation here where x has to be greater than 0, b has to be greater than 0, and b cannot equal 1. And you'll see some of that when we look at them exponentially, and then the other way you're going to be able to see these stipulation pieces is graphically. So you have to be able to move back and forth between these two forms. So one thing I want you to note is here's the base of my log, here's the base of my exponent. They're the same. They're the same. The next thing I want you to realize is a log is an exponent. A log equals an exponent, right? Log equals an exponent. That's why this y is the exponent to my base, because your log is just strictly an exponent. Okay? So, a couple of terminology pieces here. Y is the logarithm. It's the exponent. B is the base. And x we call the argument, based on this notation up here. Now, I'm not always going to put my x's and y's in those places. I may flip-flop where my x is, where my y is. You have to understand location, that the exponent is always the logarithm. The exponent is always the logarithm. Okay, whatever it could be. Instead of this being a y here, it might be a g or a z or whatever the case is. It just depends on what we're trying to figure out. So we can solve for unknown values in our logs. So here's a case. I have log base 2 of x equals 3. Okay, so the logarithm equals an exponent. Great, my exponent's 3. So what you may have to do is rewrite this. Remember, y equals log base b of x, if and only if b to the y equals x. So if it's in log form and you can't see it, rewrite it exponentially. Rewrite it exponentially. So I have it in log form, so I'm going to start with my base, 2, to my exponent. Remember, the log equals the exponent, and that equals x. So just rewriting it so that you feel comfortable. So therefore, what's x? 8. Just by rewriting something from log form into exponential form, you can figure out what your answer is. So this is where my argument was my unknown. In this case, my argument was my unknown. Okay. Next one, that answer part is my unknown. Now keep in mind, a logarithm equals an exponent. So that's the log part of it. That's the exponent. So I can rewrite this. Start with your base, 4 to the exponent, which is what your log equals 16. So now I have to kind of think about this a little bit. Now keep in mind that you're not going to be using a calculator. This one's hopefully fairly easy to see because most of you know that 4 squared equals 16. But you're not always going to have that as straightforward as possible. So what you may wish to do is factor tree. Yes, factor tree. 2 squared to the x, right? 2 squared is 4 to the x equals 2, and then 16 is 2 to the 4th. Power to power we multiply, so that's 2 to the 2x equals 2 to the 4th. It's an equation. They have to be equal. And they have the same basis. Therefore, my exponents have to be equal. 2x equals 4. Therefore, x is 2. And I am solving. I should put these in set notation. Okay. So again, if you know what it is directly because you can see it, that's fine. Just tell me what it is. But that's not always going to be the case. Sometimes you're going to get fractional exponents. Just make sure that you have equivalent statements set up there. So argument was my unknown. Answer, which is the exponent, is my unknown. Now my base is my unknown. So again, I have to rewrite this so I can see what it is. Start with your base. 2 my logarithm, that's my exponent, equals 16. Again, we're doing all of this without a calculator. Sometimes it's easier to see than others. I'm trying to work with some easy numbers right away. I need to get x by itself. I need to isolate my x. What's attached to x? So how do I undo something to the 4th? Take it to the 4th root. Now, here's the thing though. Keep in mind, we take it to the reciprocal exponent truly because I need these two numbers, 4 over 1 and 1 over 4, to cancel out, which is why it's the reciprocal exponent, okay? Which is just the 1/4 because it's the 4th power, therefore it's to the 1/4 because that's the root. So now on the left-hand side, I have just x because 4 over 1 times 1 over 4 is 1. And now I have 16 to the 1/4. Now some of you might know what the 4th root of 16 is. If you do not, 16 is 2 to the 4th to the 1/4. Power to power we multiply. 4 over 1 times 1 over 4 is 1. Therefore, x equals 2. So these are the 3 different cases of where your unknown variable x is going to be located. All a logarithm is an exponent. That's it. And we'll be rewriting our log so that we can solve in each of the 3 cases. And then keep in mind that we're going to keep going. We're going to have some properties with logs to learn. But this is just the basics to what is a log. Make sure you practice these and you have this solid. The first way is probably the easiest of the 3 when it's the argument, because you just write it out and that's your answer. Then the second direction, you may have to prime factor. Third direction, that's not the case. You have to do reciprocal exponents. Please keep in mind that each of the 3 cases will give you different answers. And the second 2, we had to have them nicely working out. Otherwise, we can't do it without our calculator. We'll have to learn how to do these with our calculator so we can evaluate all sorts of problems, such as this first one. Nope, not the first one. This one here. We will be able to use logs once we know some properties to solve that, because that's where my exponent is my unknown. So we'll learn how to work on this one in just a little while.